Hello everyone. So in this video, we're going to go through all of our radical rules and then practice using each of them. So this would be like a nice summary and review video. So what I want you to do is just to basically take notes, to write the rules at the top as well as all 12 examples. You don't have to write the rules the same way I did. I just want to have it all neatly at the top so I can refer to them, but just have the rules written down in all 12 examples in order and take notes on the ones I do, and the rest you'll be doing on your own, and I'll explain that as we go. So the first rule we went through was our multiplication rule. So this basically said when I'm multiplying with radicals, so the numbers on the outside, so in this case, the a times the c, that's just regular multiplication. So we could just do a times c, so that just stays on the outside. But with the numbers inside the radical, so here the b and the d, we can also combine those, and then those will stay inside of the radical. So basically, if we're multiplying radicals, stuff on the outside and then stuff on the inside, we can combine, and the stuff on the inside stays inside. Squaring rule, we said that square and square root undo each other, right? Because if I have the number 3, so if I have the number 3, if I square it, I'll get to 9, right? So if I want to get back to 3, if I square root it, then I'm back to the 3, right? So the square and square root undo each other. I'm just get right back to where I started from. So we said whether it's inside the radical or outside, those will undo each other. So the square and square root get rid of each other, and then we're left with just the a. And this makes sense if we just have a number. So if I have 3 squared, well, you could use our multiplication rule, because remember, 3 squared is the same as 3 times 3, which is the square root of 9, which is 3, right? So basically, when I'm squaring something, the square and square root undo each other, so we're left with just the 3. So that is our squaring rule. Our division rule basically said if I'm taking the square root of a quotient, both the numerator and the denominator needs to be getting that square root, so we can distribute. But this also works backwards. So if I have 2 square roots, I can move the square root to the outside, which means I can divide the a and the b. So if you can simplify them, so if you have like 9 over 3, you can make that 3, right? So you can move that radical to the outside. So that works in both directions. And then finally, our rationalizing said we don't want any radical in the denominator. So we basically use our squaring rule, because I'm right. If I multiply by itself, that's the same as squaring it. That's the same as b squared. And I know square and square root undo each other. So I'll get just the b. So we use our squaring rule to get rid of that radical in the bottom. And we basically move it to the top. But we want the same expression, so we're not changing the value, just with the radical out of the bottom. So let's start off with number 1. This is using our multiplication rule. So I know if I'm multiplying, I can multiply the stuff on the outside. So the 3 times 3, that's going to stay on the outside. And then on the inside, I have a radical 10 times a radical 2. So that's going to be a radical 20. Okay, so I know we see the 9. So that 9 doesn't have the square root over it. So I don't want to take the square root of 9. It's just a 9, right? So the square root of 20, though, we need to take the square root of that. So I asked myself, are there any perfect square factors of 20? Or what can I break that down to? So we should be saying 4 times 5, right? Because 4 is a perfect square. Right? Because 4 is 2 times 2. Square root of 4 is 2. And then that 5 is trapped inside of Jill. Right? And then don't forget about this 9. This 9 is just hanging out on the outside. But remember, what operation is between the 9 and the radical? So if I don't see anything there, it's multiplication, right? So times 9 is just going to stay on the outside. So once that square root of 4 comes out of jail as a 2, we can multiply those together, right? So 9 times 2 would give me 18. And then that 5 is inside of jail, so that doesn't get to do anything. So 18 radical 5 will be my final answer. And I want to stress the point. So when you're dealing with radicals, the number inside, just make sure you're not able to break that down more. So 5 is just 5 times 1. So obviously we can't break that down more. So that's how I know it's in simplest form. But you have your calculator. So even if you forget your rules, if you just play around with this and want to make sure that it's the same thing, you're free to type this in the calculator, right? Because if I type in 3 radical 10 times a 3 radical 2, well, the calculator won't simplify the radicals for us. It'll just give us a decimal. But what I can do now is I could check, is my 18 radical 5 the same as the original? Did I get the same answer? And you can see we get the same answer. So everything that we did was mathematically correct. And even if you want to type in the 9 radical 20 before we simplify it, you always have your calculator to make sure that you're doing the correct stuff with radicals, that you're not changing anything. So the calculator is an extremely useful tool. So I know without even checking without handing it in, I know I have the correct answer because 5 can be broken down and we have the same decimal. So that's a helpful way for you to check if you're working with these radicals correctly. Okay, number 2, you're trying on your own. That has the dot next to it. Number 3, we can use our squaring rule, right? Because if I'm doing square root of 12 squared, so you could think about this as either 12 times 12, where square is times by itself. So the long way is 12 times 12. Use our multiplication rule. That's 144. Right? The stuff inside the radical, we can combine those and keep it inside. And then the square root of 144, it is a perfect square. If you're not sure, you have your calculator. But 144 will give us just 12. Okay, so that's the long way, or you can use the squaring rule and basically say, okay, square root undo each other, so we're left with just 12. But the long way verifies that that is indeed correct. All right, number 4, you're trying on your own. Number 5. So here we're taking the square root of a quotient, right? 81 divided by 16, so we're dividing. So notice we can't simplify 81 over 16. You can check, but they don't have common factors. The only factors of 16 would be 2 and 4 and 8, and neither of those goes into 81. But if you want to do math fraction in the calculator, you can check, you can't simplify that. But using my division rule, remember, if I'm taking the division, we can give the radical to both the numerator and the denominator. So I could take the square root of 81 and the square root of 16. So distribute that radical. And now I can simplify it because the square root of 81 is 9 and the square root of 16 is 4. Right, so now that would be in simplified form. All right, so if you can't do the division, you can distribute the radical. So there is some way we can simplify that. Okay, for number 6, though, it looks like the same thing because 9 over 2, I can't simplify. Like obviously like 4.5 or 4.5, but I don't really want a decimal. That's not really simplified. So I can do the same thing and give the radical to both the 9 and the 2. And if you notice here, now we can't simplify both. I could do the square root of 9, right? That's equal to 3. But the square root of 2, I can't do anything with, right? That doesn't get to come out of jail. So I asked myself, is this in simplest form? Well, if I go back to the top, remember, we don't want radicals at the bottom, right? Because what do I know about what type of number is the square root of 2? Okay, so remember when we looked at up to 1,000,000 digits, but any non-perfect square, so square root of 2, square root of 5, square root of 11, anything that doesn't get to come out of jail, we said is irrational, right? You're going to get a decimal that just goes on forever, and there's no pattern here. Just 4, 1, 4, 2, 1, 3, 5, 6, 2. It just keeps on going forever. I don't know what's coming after it. I don't know what's coming next, so it's irrational. Okay, so we can use our squaring rule, because if I want to get rid of square root of 2, well, if I square that or multiply it by itself, I know the radical will go away, right? So, but I multiply both the top and the bottom by the radical 2. We'll do this in a different color. So we can multiply by that. So anytime I have a radical in the bottom, all we have to do is multiply it by itself. And then we do that to the top and the bottom because that's how I deal with fractions. So this at the top, I'm just going to get 3 radical 2. And at the bottom, you get the square root of 4, which is 2. But remember, when you multiply by itself, the square root undo each other, so the 2 is just going to come out. So this will be my final answer. Okay, and if you want to check, let's check that we did it correctly, because if you want to type in, you could do either 9 over 2 or give the radical 9 over radical 2, either one, so you get 2.12, blah, blah, blah. And if you type in our new answer, so 3 radical 2 over 2, you can check, we get the same thing. So we know we are correct. Okay, so use that calculator as a tool to check your answers. All right, going to the right column here. So number 7, you're going to be doing on your own. So let's talk about number 8. So here we have 2 radical 3 over radical 12. So I like problems like these because I'll show you a bunch of different ways, but no matter whatever way you're comfortable with, we're going to get the same answer, right? So if you want to, let's look at it a few different ways. So first off, with that radical 12 down below, if you want to simplify that, if you probably will realize, okay, I could break that down, right? That's 4 times 3, right? And I know the square root of 4 is 2, right? So this is going to be ultimately 2 radical 3, right? So if I change that denominator to 2 radical 3, you'll notice, well, the 2's cancel. So 2 divided by 2 is 1, And then radical 3 divided by radical 3 is 1, right? So we're just going to get 1. So if you want to use your simplifying to manipulate that, that's perfectly fine. Some of you may notice first, well, I have 3 over 12. Since they're both in the radical, I can use my division rule. Since they're both in the radical, I can divide them, right? So if I do it that way, well, 3 over 12, you should know is if you divide them both by 3, 3 divided by 3 is 1. 12 divided by 3 is 4, so it's 1 over 4. You have your calculator as well. So some of you might be like, okay, we can make that, since they're both inside, we can make that 1 and 4. Okay, and then now, well, the square root of 1 is just, well, 1 times 1, right? So 2 times 1. And the square root of 4 is 2. So basically, we'll also get 1 as our answer. Okay, and if you want to say you don't realize either of those, well, maybe you're just like, okay, I have a radical 12 down below, and I don't want a radical 12 down below. So what I can do is I can multiply by radical 12. Right? Because I know at the bottom, now I'm just going to get 12, right? Multiplying it by itself undoes the radical. And at the top, I could combine the 3 times the 12 in Joe. So 3 times 12 is 36. All right, and then the square root of 36 is 6, right? Okay, so at the top, we're going to have 2 times 6, which is 12, over 12, which is 1. So bunch of all these ways work. No matter what, we get 1. So whatever you're more comfortable with. Personally, I probably do the first or second way, but if you want to rationalize it, you'll get the same answer as well. Okay, let's look at number 9 here. So number 9, we can't simplify radical 15, so we can't do it the first way, breaking it down. So I think the easier way, if you notice 6 over 15, well, 3 goes into both of them, right? So 3 over, if you divide them by 3, 6 divided by 3 is 2. 15 divided by 3 is 5, so that's 2 over 5. Or the calculator will also tell you 2 over 5, math fraction. So if you want to do it that first way, you can basically, remember, if I have that 6 over 50, that radical over both, we can pull it out, use our division rule, put it over the entire thing. So that'll become 2 over 5. So if you want to divide those and make those 2 over 5, that might be a good way to start. Okay, and then we can't do it like last time and simplify. So if I have a radical 5 down below, we have to multiply by radical 5 to rationalize that. Okay, so now that 5 will come out down below, right? Because you get the square root of 25, which is 5. And at the top, we have a 3 times, so 2 times 5 is radical 10. So 3 radical 10 over 5. So you kind of have to do the simplifying and that. If you start off multiplying by radical 15, because that's at the bottom, you'll get 15 times 6, which is, 15 times 6 is what, 90? So you're going to get some big numbers. If you rationalize it, you get like 3 radical 90 over 15. But then you could break down that's 9 times 10, so that you could break it down. So you get a bigger number in a little bit longer way, but you'll get the same answer ultimately. And if you type both of these in the calculator, you can check that you get the same decimal. All right, number 10, you're doing on your own. So let's finish this video with number 11. So for number 11, I just want to talk about being strategic with these radicals. Because like I showed you, there's a bunch of different ways you can do it. You'll get the same answer. But sometimes you might find ways that are less work, right? Because if I look at this one, that square root of 4 is tempting, right? Because I could use, well, square root of 4 is 2, right? But if I do that, we're going to be left with the radical down below because 18 doesn't come out of jail. So even if you simplify 18, right, that's 9 times 2. And the square root of 9 is 3. And then radical 2. So even if you do that way, I'm going to be left with a little bit of work here because I'm going to have to multiply top and bottom by radical 2, right? So since I have a radical 2 down below, we'd have to rationalize that. So I could show you this way. It's longer, but then I could show you, I think a quicker way you might notice. It would be a lot easier, right? Because at the top, we'll have 2 radical 2, just smush them together. And at the bottom, well, I know if I multiply that by itself, that's just going to, the 2 is going to come out, right? Square root of 4 is 2. So I'll be left with, and we have this 3 here. So 3 times 2 is 6. Okay, is there anything else I could do here or am I done? So you might notice I have 2 over 6 both on the outside. So I can make that 1/3. So ultimately I'm going to have radical 2 over 3. Okay, so you can see that was a lot of work, right? Because not only did I simplify a radical at the bottom, right? This 18, I made 3 radical 2, but then I had to rationalize as well and simplify. So it involves simplifying radicals, rationalizing, and then simplifying fractions or dividing here. So definitely a lot of work. So I think a strategic way you might notice, if you notice you're doing a lot of work, is these are both under the radical, right? So what I can do is I can put the radical over the entire thing, right? So I could do 4 over 18. Or basically, if they're both inside the radical, I could divide. So 4 over 18, if I divide them both by 2, right? This is 2 over 9, right? This is 2 over 9. So I can make this 2 over 9. And then just like the 4 in the first step, once I do that, just single step, the square root of 9 comes out as 3, right? So 2 is at the top and then 3 is at the bottom. So you'll notice we get the same radical 2 over 3, but just a lot simpler, right? So don't be, always look at the easiest way to go. Because yes, the square root of 4 is tempting to make that 2, but if you do that way, you'll notice you'll be getting 9 at the bottom, and then that gets out of jail. So once that comes out of jail at the bottom, you don't have to rationalize it because there's no radical at the bottom. So that way it's a lot easier. So just in general, try to be strategic about these. So you can do number 12 on your own. So those are 12. Hopefully that was good practice. Hopefully you were able to follow along, get more comfortable with this. And we'll be practicing while we're doing our geometry topics with this as well. But so we'll get that additional practice. So hopefully we're more comfortable with this now. All right, that's all. Goodbye.